trigonometric functions. So now we have sines of trigonometric functions in a given quadrant. So the coordinate system is divided into quadrant. Okay? This is my first quadrant. This is my first quadrant. This is my second quadrant. This is my third quadrant. And this one is my fourth quadrant. That's how the coordinate system is divided into quadrants. Now, in the first quadrant, all trigonometric functions are positive. So I'm gonna write this, that all positive. That is, sine is positive, cosine is positive, tangent is positive, and the reciprocal of them. And now in the second quadrant, on the sine is positive. Sine and its reciprocal, those are for primary. Sine is positive. So sine is positive, cos is negative, and tangent is negative. And reciprocal of sine is cosecant is also positive. Okay? And in the third quadrant, tangent is positive. Only tangent is positive, and it's reciprocal. And in the fourth quadrant, cosine. Only cosine is positive. So how do we remember? How do we remember this? A stands for all, S, T, C. That's how we remember this. A, all positive, sine positive, tangent positive, and cosine positive. This is about the first three primary trigonometric functions, because reciprocal goes accordingly. Okay? So if sine opposite of sine is of course cosecant, so we can write it for this one, cosecant is positive as well, and all the other are negative. Tangent, reciprocal is cotangent, is positive, and cosine secant is positive. Okay? So how can we remember this? A, C, T, C, A, S, T, C. We had this story. There are several stories actually. We say that one of them is add sugar to coffee. Add sugar to coffee. Add sugar to coffee, or you can go that all students like calculus, all students all students take calculus, and there are other stuff. You can just make up your own story to remember this. For me, the easier one is remember add sugar to coffee, and that gives me the signs of the trigonometric functions. And we do use them very, very often. So here is example 1. Name the quadrant in which the theta lies. If we have given information A, and we had that sine theta, we had the cos theta is greater than 0 and tangent theta is greater than 0. Okay, so greater than 0, that means cosine is positive, and tangent greater than 0, that means tangent is positive. So I make my chart, I make my quadrants, I start with the story, add sugar to coffee. That means cosine is positive. Cosine is positive in the first, it's all of them. Cos is positive. And in the fourth quadrant, cos is positive. Tangent is positive in the first, all of them are positive, so tangent is positive in the first, and tangent is positive in the third quadrant, because it goes 1, 2, 3, and fourth. So where those two conditions are satisfied is just my quadrant 1. So name the quadrant. This one is in quadrant 1. Both conditions are satisfied in quadrant 1. Example 2, another example B. B, we have that cosine theta is greater than 0. Cos theta is less than 0, is negative. And we have that sine theta is greater than 0. Okay, so we have that cos is negative, and sine is greater than 0 means positive. So make the chart, check where those two are positive. So we have add sugar to coffee. So that means in the first one, cos is positive, and cos is positive in those two. Right? We can write this actually if you wanna, but we are looking where is cos negative. So cos is negative in this one, cos theta is negative, and cos theta is negative in this quadrant. And this one was my 1, 2, 3, and fourth quadrant. Because in the first one all of them are positive, so cos is positive, and C stands for cos positive. And now sine must be positive. Sine is positive in the first one, and sine is positive in the second one. So where those two conditions are satisfied, I'm getting cos negative, sine positive, so that's the quadrant. So the answer is that the theta lies in the second quadrant. In the second quadrant. And what does that exactly mean? The situation looks like this. The situation looks like this. If you had the angle theta, the angle theta keeps opening, and in that case the angle theta finish in the second quadrant somewhere here, because sine is positive, negative, and cos is negative, and the angle theta can keep opening. It can end up in the third, or it can end up in the fourth, or it can start with the first quadrant. Okay, that's basically the meaning of those ones. One more example, identifying the quadrant. So we have C. We have C, that sine theta is negative, and cotangent theta is positive. Cotangent, we don't have cotangent, we have primary trig functions, but cotangent is nothing else but tangent, reciprocal, 1 over tangent, right? Cotangent is 1 over tangent. So the sine, they will have the same sign. So if cotangent is positive, that means tangent must be positive as well. Sine is less than 0, so sine is negative. So we had the story: add sugar to coffee. First identify where the sign is negative. Sign is negative. Here all positive, sign positive, so sign is negative right here. And right here sign is negative. And the quadrant where this one was first, second, third, and fourth quadrant. Okay? And now cotangent means tangent is positive. Tangent is positive in the first one, all of them are positive. So that means cotangent is positive. And tangent is positive right here. That means cotangent is positive right here. So the two conditions that sine is negative and cotangent is positive, sine negative, cotangent positive, that's this quadrant. So the answer is that my theta lies in the third quadrant. Quadrant 3. Definition of a reference angle. A reference angle is an acute positive angle formed by the terminal side of the given angle theta and the x-axis. For example, if my angle has initial side right here and the terminal side right here, that's my angle theta. So the reference angle is formed by the terminal side, and by the x-axis. So right here is my x-axis. So this is nothing else but the reference angle. Or we can write that this is theta ref. Okay, is the acute positive angle. Reference angle is always positive. If we have the angle, another example, if we have the angle that starts right here and keep going up to here, for example, this one is my theta, then the reference angle is not the small one, is the angle between the terminal side, so that's this angle, that's this side, and the x-axis. So right here we have the theta reference. We have example, find the reference angle of each given angle. And we have A, 320 degree. Okay, so I draw the angle 320 degree. I know that if I start from the initial at 0, this one is right angle 90 degree. If I open even more, I have straight angle 180 degree. If I open even more, it would be 180 plus another right angle 90, so it's 270. And if I go full rotation, this starts from 0 and 360 degree. So right here is my angle 320 degree. Okay, how much I am short? How much I am short to complete the full rotation? How much I am short to complete the full rotation? 360 minus 320 is 40 degree. So this angle is 40 degree, and that's my reference angle between the terminal side and the x-axis. So theta reference is 40 degree. Example B, 5 pi over 4 radians. We do need to be able to work with degrees and with radians. So I draw my chart. I draw the coordinate system. Okay. When I start here is 0, my initial arm, and then when I go here it's 90 degree. 90 degree is nothing else but pi over 2. When I go over to the full, it's 180 degree. 180 degree is pi. When I go full rotation, I have 2 pi. 360 is 2 pi. Okay, but that doesn't tell me anything because I have 5 pi over 4, and this would be 1 pi and a half. So this one is 3 pi over 2. But now I need to keep thinking in force. So 1 pi or 1 is nothing else but 4 over 4. So this one is 4 over 4 pi. That's my 1. 2 pi, 2 is nothing else but 8 over 4. So this one is 8 over 4 when you divide it's 2 and pi. So where is my 5 pi over 4? 5 pi over 4, I keep opening my angle. I keep opening my angle. I keep opening my angle, and I get to 4 over 4, and it's a little bit more than 4 over 4. So the angle is right here. The whole one is pi over 4. Pi fourths, 5 fourths pi, 5 fourths pi. And now, how much more did we go? We have 4 over 4 to get 5 fourths. How much did we go? 1/4. So this one is 1/4 farther than 4 fourths, right? So this angle is 1/4 pi, or in other words, pi over 4. So the reference angle, theta reference, is 1/4 pi, or this is the same what pi over 4. You can think this is like over 1 and multiply this. Pi over 4 is my reference angle. Let's do one more example. We have C. I have minus 7 pi over 6. So now I need to go the opposite direction. So I start from 0. I keep opening this way, the opposite direction. So this one up to half, this would be my pi. Here in the middle is pi over 2. And I keep opening, minus pi. This would be minus pi over 2. And if I keep going backwards, this would be minus 2 pi. And if I am right here, is minus 1.5, so minus 3 pi over 4 if I go this direction. So now I need to keep thinking, in sixes. So 1 pi is nothing else but 6 over 6 pi. Okay, so we are starting from this one. We are starting from this 0. This one is my initial arm, and I keep opening this way, 6, and I need to go one more, so this one is right here. So this angle is minus 7 pi over 6. And if you wanna that we go opposite direction, it's minus. So if this one is 6 over 6, how much more did we go to get 7, 6? We went 1/6 more. 1/6, so it's pi over 6. So my theta reference is 1/6 pi, you can think, or write that this is pi over 6. Now we have theorem that all trigonometric functions of an angle theta are equal to the equal to the plus or minus of the trigonometric function of the corresponding reference angle. The plus or minus is chosen according to the quadrant in which theta lies. So all trigonometric functions of a general angle are equivalent to the trigonometric functions of the reference angle up to plus or minus. So to find the exact value of a trigonometric function of a general angle, follow the steps. Step 1, find the reference angle. Step 2, adjust plus or minus according to the quadrant your angle is. And step 3, find the value of the function using the chart or other. Example, find the exact value of each function. So we have A, we have sine 240 degree. So first find the reference angle. We're gonna draw this 240 degree. Okay? When I start and keep opening my angle, I keep going. So in this one 90 degree, this one is a straight angle, is 180 and a little bit more. So here was 90 degree, 180 and a little bit more. So we are right somewhere here. This one is 240 degree. So if this angle is 180, how much more did we go from 240? From 240 minus 180 gives me nothing else but 60 degree. So this angle is 60 degree. So my reference angle, theta reference, is 60 degree. So now we need to know in this quadrant, this is the third quadrant, sine is positive or negative. So I go with my story, add sugar to coffee. So in this quadrant, only tangent is positive, so sine is negative. So the sine 240 degree is equivalent to the sine of the reference angle up to the sine plus or minus. So sine 60 degree plus or minus, but depends which quadrant we are. We are in the third quadrant. Sine has negative value in this one. So it's minus sine 60 degree. And then I'm using my chart. Sine 60 degree is nothing else but, we can make this small chart. Here was 30, 45, 60. Sine was the first one, over 2, over 2, over 2, and on top was 1, 2, 3, and there was square root. So sine 60 degree is root 3 over 2, so then we have minus. Example 2. find the exact value, so this is my B. Find the exact value of tangent 9 pi over 4. 9 pi over 4. So first we need to find the reference angle. Now we need to think in terms of pi. If I keep opening from this one, here is my 1 pi, straight angle 180 degree. If I open it to full rotation, I will get to 2 pi. Okay, and this one is half pi, pi over 2, or this one would be 1 pi and half, so it's 3 halves pi. So now I need to keep thinking in terms of fourths. Now I need to keep thinking of fourths. So 1 pi, 1 is 4 over 4. If I go further, 2 is 8. 2 is nothing else, 8 over 4 pi. And we have 9 fourths. So 9 fourths went 1 over. So the angle would end up right here, and we went 1 and a little bit more. So the question is, how much more did we go? Here is 9 fourths, and this one is 8 fourths. So 8 fourths, how much more we went? 1/4. So this reference angle is right here, and it's pi over 4, or 1/4 more. Okay, theta reference. So tangent 9 over 4 is nothing else but the tangent of a reference angle. So reference angle is pi over 4 up to the sine, plus or minus, we need to complete the sine. So we start with add sugar to coffee. In this first quadrant, all functions are positive, so this value is positive. So now we are using our little chart. Tangent pi over 4 is 1, so the value is 1. One more example. Sine 540. Or let's do cosine C. Cosine 540 degree. Cosine 540 degree. So first draw the. So first draw this one. Okay, so we have, if we start from here 90 degree, 180, then we go further, it's 360, and if we go 360 plus 90, 360 plus 90 is 450, and plus 90 is 540. Let's do 570. Let's do 570. 570. Okay. So now we can draw the angle. We can draw the angle. We will end up right here. We went one rotation 360, and then we go to 180, and then 540, and a little bit more. So 570. How much more did we go? 570 minus 540 is 30 degree. So this one is 30 degree reference angle. My reference angle is 30 degree. So cosine 570 degree is equivalent to cosine of reference angle up to the sine. So add sugar to coffee. In this quadrant, only tangent is positive, so cos is negative. We need to put minus. And cos 30 degree is nothing else but root 3 over 2. So this value is root 3 over 2. And now we have example 5. Find the exact values of the 6 trigonometric functions. Find the exact value of the 6 trigonometric functions of the given angle. So we have the angle A. We have the angle of 4 of 5 degree. Okay, so as before, we find the reference angle. So if I keep opening 90 degree, 180. If I go full rotation is 360. So how much more did we pass 360? So we're gonna end up right here. We have this angle is 405. And how much more did we pass is 45 degree. So the reference angle, this angle is 45 degree. That's my reference angle. And now we need to get the all 6 trigonometric function. So sine 405 is the same what sine in this quadrant up to the plus, sine 45 degree. Sine 45 degree, and we are in the first quadrant. Add sugar to coffee. In the first quadrant, all trigonometric functions are positive, so this value is positive. Sine 45 degree is root 3 over 2. Cos 405 is equivalent to the cos 45 degree up to the sine plus or minus, so this is first quadrant, we are positive, so cos is root 2 over 2, root 2 over 2, root 2 over 2. Tangent 405 degree is tangent 45 degree. Sine is positive, so it's plus. Tangent 45 degree is 1. And then reciprocal, sine is cosecant 405 degree is the inverse of this one, so it's nothing else but 2 over root 2. Secant 405 degree is the inverse of cosecant of cosine, so it's 2 over root 2. And then we have cotangent 405 degree is the inverse of 1 over 1, which is 1. Example B. Example B. Four pi over 3. So first we need to find the exact value of the 6 trigonometric functions of this angle. So first we need to find the reference angle. If I keep opening, this one is my 180 or pi, and we need to keep thinking in terms of 3. So pi is 3 over 3. and we have 4/3, so we have 1/3 more. So this one is 4 pi over 3. So my reference angle, this small angle, how much more did we go? 3/3, and to 4/3 we go 1/3 more, so pi over 3. So theta reference is pi over 3, or 1/3 pi. So now sine 4 pi over 3 is equivalent. We need to have the add sugar to coffee, and in this one only tangent is positive, so sine will be negative, so I have minus sine of the reference angle pi over 3, and we need to find this value. We can record our chart. I have 30 degree, 45 degree, 60 degree, and 3 changes to 6 pi over 6, 4 stays the 4, and 6 changes to 3, and this one was sine, so it was over 2 over 2 over 2. On top was 1, 2, 3, and roots. Cosine was opposite way. Cosine was from the back, this one, and tangent. So this one is root 3 over 2, root 2 over 2, and this one was 1/2. And tangent, we divide those two. So this when we divide is 1, when we divide is root 3, and when we divide, flip this over, so it's 1 over root 3. Okay, so sine pi over 3 is root 3 over 2. We have minus root 3 over 2. Then we have cos of 4 pi over 3 is equivalent to the reference angle cos pi over 3. And in the third quadrant, in this quadrant, tangent is only positive, so cos is negative. So cos pi over root 3 is negative 1/2. Tangent 4 pi over 3 is equivalent to the tangent of reference angle, tangent pi over 3. In the third quadrant, only tangent is positive. I'm gonna put the plus to make sure. So tangent pi over 3 is root 3. And then we have reciprocal function. Cosecant 4 pi over 3 is the inverse of sine, which is minus 2 over root 3. Flip this over. And then secant of 4 pi over 3 is inverse of cos. Flip this over, which is minus 2. And cotangent 4 pi over 3 is the inverse of tangent, so we have 1 over root 3. Another example, a point on the terminal side of the angle is in standard position is given. Find the exact values of the 6 trigonometric functions. So we have the point minus 3 and 4, minus 3 and 4. Okay, so we draw the coordinate system. We find the point minus 3 and 4. Right here is my minus 3 and 4. Okay, so that's the point and that's the angle. So we are looking for reference angle. The reference angle is right here. So if I create a right triangle, right here, this is my x value, and this value has 1, 2, 3, so this value has 3. This is my y value, and the value is 4. I need to find this r. I'm using Pythagorean theorem that r squared is equal to 3 squared plus 4 squared. So r squared is equal to 9 plus 16. So r squared is 25. Take square root. So r is equal to root of 25, which is 5. So this side is 5. And now we are in this quadrant. Now we are in the second quadrant. So if I take my add sugar to coffee, I have that only sign is positive in this quadrant. Okay, so 6 trigonometric functions. Sine theta, my theta would be the general angle. Sine theta is equivalent to the reference angle. Here's my reference angle. In this reference angle would be opposite over hypotenuse. So this one is 4 over 5. And then we are in the second quadrant, sine is positive, so that's it. Then I have cos theta. Cos theta is adjacent over hypotenuse, so it's 3 over 5. But now I am in the second quadrant, so the value is negative. You can think that's minus 3. And then we have tangent is adjacent over is opposite over adjacent, so it's 4 over 3. And we are in the second quadrant, so the tangent is negative as well, because it would be like minus 3 over 4 over minus 3, which is negative. And then we have cosecant theta is inverse of sine, which is 5 over 4. Secant theta is inverse of cos, which is minus 5 over 3. And cotangent theta is inverse of tangent, which is minus 3 over 4. Another example, find the exact value of each of the remaining trigonometric functions. If we have given a, that sine theta is equal to 2/3, and we have 90 degree is less than theta less than 180 degree. So this information tells me the quadrant, and this information gives me the value. So if I draw the right triangle, I'm gonna be 90 degree, 180. I'm in this, I'm right here. I'm in the second quadrant between 90 and 180. Okay, so now opposite over hypotenuse. So we have opposite over hypotenuse. Here's my reference angle. I need to find this value x. I'm using the Pythagorean theorem. X squared plus 2 squared is equal to my hypotenuse squared, which is 3 squared. So I have x squared is plus 4 is equal to 9. Bring the 4 over. X squared is equal to 9 minus 4. So x squared is 5. Take the square root. So x is square root of 5. So this one is square root of 5. And now I need my story add sugar to coffee. So first I have sine theta is sine theta is equal to 2/3. Then we have cos theta is equivalent to the reference angle. So reference angle is adjacent over hypotenuse, so it's root 5 over 3. and we are in the second quadrant, so the value is negative. Okay, and then because my angle theta is this one, theta is my angle this one, and this is the reference angle. Okay, and then we have tangent theta. Tangent theta is opposite over adjacent, so 2 over root 5, and in the second quadrant on the sign is positive, so we need to put minus. Or you can think that this one is minus root of 5 because it's negative. Okay, so sine, now we have cosecant is inverse of sine, so it's 3 over 2. Sine is secant is inverse of cos. Secant is inverse of cos, so we have minus 3 over root 5. Tangent, cotangent is inverse of tangent is minus root 5 over 2. B. I have that tangent theta is equal to minus 1/3, and we have that sine theta is greater than 0. So first we would like to decide what quadrant we are in, using the information that tangent is negative and sine theta is positive. So we have add sugar to coffee. Tangent is negative, in this all of them positive, so here tangent is negative and tangent is negative in this quadrant. Here tangent is positive and all of them are positive. Sine is positive in the first one and sine is positive in the second one. So tangent negative and sine positive, that gives me second quadrant. So based on those two informations, that tangent is negative and sine is positive, I know that I am in the second quadrant. Okay, so now I can draw my triangle. Now we can draw the triangle. We are in the second quadrant, so I'm using the reference angle. This would be my reference angle. Okay, and a reference angle is right here, theta. Theta ref. Okay, so tangent is opposite over adjacent. So opposite is 1, adjacent is 3. If you think, you can say that this one is minus 1. And then I need to find this value. I call it this value r, using Pythagorean theorem that r squared is equal to 1 squared plus 3 squared. So r squared is equal to 1 plus 9. So r squared is equal to 10. Take the square root. So r is equal to square root of 10. So this one is square root of 10. Now we need our story to know which one we are. Add sugar to coffee. Once you decide which quadrant you are, you can always put minus here, because this one is on negative and this one is positive. You can put that this one is minus 3. This might help you. So sine theta. Sine theta is opposite over hypotenuse. Opposite is 1, hypotenuse is root 10. And in the second quadrant, sine is positive, so the value is plus. Cos theta is adjacent over hypotenuse, so it's 3 over root 10. And in second quadrant, only sine is positive, cosine is negative. Tangent theta is given minus 1/3. And then the reciprocal one. Cosine reciprocal is cosecant. Cosecant theta, flip over the value, so it's root 10 over 1, which is root 10. Secant theta, flip the value over, root 10 over 3. And cotangent theta, flip the value over, minus 3 over 1, which is minus 3. And that concludes this section. Thank you.